We have a thin walled tube with closed ends, and it contains a pressure of 10 MPa and is also subject to a torque of 3000 Newton meters. We also know the dimensions for the tube. In part A, we will determine what is the safety factor against yielding if the material is ASTM A514 T1 structural steel. And in part B, we will discuss if the design is safe or not, and if it is not, we will suggest a new material. Let's first calculate the stresses. We know that for a thin walled tube with closed ends, sigma R is equal to 0 at outside and minus P, minus pressure, at inside. Sigma X is equal to pressure times radius over 2T, and finally sigma theta is equal to pressure times radius over thickness. Now let's calculate the stresses substituting the values. Sigma X will be equal to 10 MPa times 20 millimeters over 2 times 2.5 millimeters, which is 40 MPa, and sigma theta will be 2 times sigma X, and it is 80 MPa, and finally sigma R will be minus 10 MPa. Now let's calculate the shear stress tau T caused by the torque. We know that tau is equal to Tc over J, and we know that for a thin walled tube, the polar moment of inertia is equal to 2 pi R average cube times T, where R average is equal to D over T plus D over 2 plus D over 2 plus T over 2, and this gives D plus T over 2. And in our case, our average is 42.5 over 2, so it is 21.25 millimeters. So let's calculate tau T. It will be equal to T times R average over 2 pi R average cube times T, and it is 3000 Newton meters over 2 pi 21.25 millimeters square times 2.5 millimeters. And we obtain tau T as 422.94 MPa. Since we know the stresses, we can now calculate the principal normal stresses. Sigma 1 will be 15 plus, this is equal to sigma X plus sigma R over 2, plus 25 square plus 422.94 square, and sigma 1 is equal to 438.68 MPa. And sigma 2 will be 15 minus 25 square plus 422 plus 94 square, and it will be minus 408.68 MPa. And we know that sigma 3 will be equal to sigma theta, which is 80 MPa. We can find the safety factor against yielding using Tresca. According to Tresca, we will have a sigma s, which is equal to the maximum of sigma 1 minus sigma 2, sigma 1 minus sigma 3, and sigma 2 minus sigma 3, and it should be smaller than the yield strength. In our case, sigma s is equal to 847.36 MPa. It is equal to sigma 1 minus sigma 2. And we know that ASTM A514 T1 structural steel has a yield strength of 724 MPa from table 3.2. So we can say that the safety factor will be the yielding strength over sigma s, which will be 724 over 847.36, and it is 0.854. This value is smaller than 1, so we can say that it is not safe. So we should find another material to have a safe system. For this tube to be safe, the yielding strength should be bigger than 847.36. When we look at table 3.2, we see that AISI 4142 steel has the yield strength equal to 1378 MPa, and it will give a safety factor of 1.63, which is larger than 1. So we can say that AISI 4142 steel, 450 degrees tempered, is enough to satisfy safety factor larger than 1.